right, so welcome everyone. So we are back with our series on fallacies of distributed systems. So we are here with Mark Richards. And Mark, you have already enlightened us with a lot of these fallacies. Please have your say on our next fallacy.
Fantastic. As a matter of fact, Rohit, I think on this particular podcast, we're going to group two fallacies because like the prior one, we're going to see two that are actually related. And what I want to talk about in this particular fallacy or this particular podcast is really fallacy number 5. The topology never changes. Now, what this fallacy is really saying is that the topology, and I'm talking about the network, and this is the actual network itself, the routers, the switches, the hubs, the gateways, the firewalls, all this stuff, we make an assumption as architects, designers, developers, and analysts that this is a static infrastructure that always remains the same. And in fact, that's why it's a fallacy. Topology constantly changes all the time. Now, I bet you're wondering, who cares? So let me give you my 2 cents, Rohit, and I bet you have some other 2 cents worth. We talked about 4 fallacies in the prior podcasts. The fact of fallacy number 1, the network is reliable. Fallacy 2, latency is 0. Fallacy 3, bandwidth is infinite. And also fallacy 4, the network is secure. As a matter of fact, all 4 of those that we previously talked about are kind of linked to this. Let me give you a scenario. So let's say that you come in Monday morning and you know this is going to be a much better week than last week because last week was just horrible. And you come into work and everybody's running around like crazy. And you're like, what's going on? And somebody points to the Hystrix console or Prometheus or even Kubernetes console and says, look, all the services, when they come up, they start processing and they immediately go down and it's spinning more up and then they come down. What's going on? Well, of course, when these kind of things happen, the very first thing you say is this, okay, who deployed this weekend? No one. There was no software at all deployed. So after 2 hours, what you come to realize through root cause analysis is that there was a major network upgrade at 2 a.m. that morning. You see, the topology continually changes, whether it be on-prem or even cloud topology. And the problem is this, we make all our assumptions about latency, bandwidth, reliability, based on a static snapshot of that topology. And every time it changes, Rohit, it possibly, and usually does, invalidate all of our assertions and assumptions about all those other conditions and fallacies that we just previously talked about in other podcasts. And so that's the significance of this. We base bandwidth, latency, and reliability metrics on that topology.
Yeah, actually, one of the things which is really critical here, people need to know it and learn it, put it in their head, that they should actually look at the capacity. They should look at what capacity they are in at any given time.
Yep.
And what happens, like even if you're using AWS or any other service you're using, you need to be proactive in terms of when are you changing that topology. So that means like even if the upgrades are going on or behind the scene, the servers are getting rolled out and those communication needs to take place. And you need to be aware of what's really happening to your services. Let's say you have 3 or 4 vendors. You are critically really want to understand what are their capacity. What is their capacity? When are they planning to have a newer version coming out? So you can plan your version accordingly. So you're not surprised by these things. So these are seasonal. Most of these things are seasonal. We can say, oh, Monday morning, these things are going bad. Or every 3 months, we have some problems like this. So I think that's where, comes down to is like, one is topology. The other part to this is like the way you are saying that is critical. From my side, like, no vendor lock-in. That's what another thing I was telling you before that like is important. So
Exactly.
using like, either Terraform or like, some way instead of just connecting with AWS, if you're using CloudFormation, that's good. But if you're using Terraform, now you have ability to test your infrastructure
Mm-hmm.
in-house, as well as in Azure, as well as in Heroku, any configuration you want.
Yeah. Yeah. So you're right. What we try to do is divorce ourselves as much as possible from the topology, knowing that it changes. But it's kind of an interesting twist in my mind or balance, because also we do rely on the network for distributed computing. And that includes cloud-based infrastructures as well.
Mhm.
And so I think that's a good approach. Understanding that the topology changes is to abstract us from that enough to where we can, what's the word? Uh, uh, take into account, handle those kind of changes. We can adapt to those quicker. So yeah, this is, well, it's interesting because even with your solution there, Rohit, the topology constantly changes. And my
Exactly.
scenario from Monday morning,
Yeah.
well, how was I supposed to know that?
Yeah.
Oh, that's easy.
Mhm.
Just talk to your administrator.
Exactly.
And that points to fallacy number 6 of distributed computing.
Absolutely.
Fallacy number 6 states there is only one administrator. And in fact, that is a fallacy, folks. Your company or even your cloud deployment vendor has dozens to maybe even hundreds of network administrators. And now we start to see the complexity of distributed computing. Because if I need to know the latency, who do I talk to? There's not just a single administrator. What about our bandwidth? What's my current bandwidth utilization? We're going to roll out a new set of services that are all orchestrated next week.
Mhm.
What kind of bandwidth am I going to consume from that? Who do I talk to about security? Who do I talk to about changes being applied across our infrastructure or even in cloud? And so the point is, this just points to the mind-blowing complexity an architect or developer has when it comes to distributed computing.
Yeah. So, I mean, why do you say that, like, why administrators are so important? Like, I mean, what do you think, like, what's different? Like, isn't it like there is one administrator doing all the work, or there are different ones?
Oh, much different ones. And as a matter of fact, different administrators have different roles within different systems or subnet responsibilities, or even security for that. We may have a security administrator who's responsible solely for security. They don't even know or care what the latency or bandwidth issues, or what the latency and bandwidth is in our network, or when
Yeah.
changes are occurring. Their focus, their scope, their responsibility is on the security of the network. And so the roles of the administrator are varied, and consequently, most companies have different roles for those particular, or different people for those particular roles, which makes it really complex to collaborate with network administrators
Mhm.
in a highly distributed environment, because all these things matter. And that's the problem. And how do we get that information?
Yeah, exactly. And one of the thing is, like, another thing is, like, if you have an administrator, that administrator should have definitely access to all the configuration data. Does the administrator need to have access to the customer data? Maybe
Oh,
not. If that person is just looking from the configuration point of view, that would be a separate administrator. And so that's where it comes down to, like, when can we lock it, like, this is only available for this to this duration of time. If they are in VPN in, or there's a two-factor authentication going on, plus still the functionality is still there, so you need to control functionality, what functionality we want to give to the administrator also.
yeah,
So that's
precisely, which is part of this whole fallacy defined by Peter Deutsch in 1994. And that was the fact that administrators do, and to your point, Rohit, should have different roles and different access rights within the network. Oh, absolutely. Yes. And so this is a fallacy to just consider that we have and a network administrator. Now maybe a small company might just have one or two people, but as companies get larger, now we're talking potentially in the dozens, and also geographically dispersed as well.
Mhm.
And so while we may have a network change in the US, it all of a sudden impacts European operations from a failover standpoint or a load balancing standpoint. And so yeah, it just even becomes more of a problem when we start talking about globalization of these networks.
Yeah, great. Well, I really loved, this talk. So this talk was basically on the topology, and it does not change, but like we have to assume that the other part which Mark discusses, the administrator, try to make sure that you have access control for them, and what they have access, what functionality you are trying to provide to them, that will really protect ourselves. So we were talking about fallacies of distributed systems. We'll have one last in this series, and we'll talk about more with Mark on transport and network implementations and their fallacies. Thank you, Mark, for your time.
All right. Bye-bye.